Now let's come over here and graph the piecewise function. So it's very much the same thing as evaluating, except you're going to have to find more points. And it also helps if you already know what the equation looks like. So now we're going to graph the function that we already played with. Again, to graph, it'd be nice if you can identify what kind of equation you're dealing with. So for example, let's graph this one. This is a linear equation. So when I look at x plus 3, this function right here, I know it's linear. So I'm expecting to get a linear equation. And to graph a linear equation, all I just need is 2 points. So one thing you can do is pick a point that is, for example, less than -4. So we can do that. So try f of, let's say, -6. Enter that here. And that gives me -3. So that produces the order pair, -6, -3. So -6, 2 and 3, halfway here. It's 1, 2, 3, 4, so halfway. There's 3, -3. So there's 1 point. Now, again, you can also, if you were familiar with how to read this, there's a couple ways to go about. I mean, this is a line. You can use this rise over run. The slope of this line is 1. So once you establish a point, you can start going and read, 1 up, 1 over, 1 up, 1 over. Another possibility, again, this is rise over run. If you have forgotten a little bit about that, then, I would just kind of review that. So another thing to remind ourselves is that this is the y-intercept. The y-intercept is here at 0, 3. So another point on this line is 0, 3. Now, where is that? It's right here. But I marked this wrong now. It's right there. Yeah, 1, 2, 1, 2. Yep. Okay. Sorry, I missed the spot there. Now, of course, 0 is not within the domain of this, but where's -4? -4 is right there. What I can do is the following. And do I include -4? No, I do not. I can connect these 2 points, but I'm not going to draw the straight line because there's nothing here. This line only exists if you're less than -4. So there you can see where -4 is located. So I'm going to put my pen here and then draw. This goes out to infinity, less than -4. So it continues. So I'm going to draw a little arrow here and put a little open circle there to remind the reader that there's nothing there at -4. Okay. And what about this point that I used? I'm just going to erase it. Okay. That's a simple way of doing it. So I'm just using what I know. Now we have between -4, including -4, and 0. What happens at that point? Well, at that point, the function is just a 6. So no matter what I enter, so if I enter -4, what do I get back out? 6. If I enter, so again, just do this for fun. -4, the answer is 6. If I enter 0, the answer is -6. So what do I get? I get a horizontal line. And it looks like it equals -4. So at -4, I come over here, and no matter what, it equals 6. But at 0, notice I'm not including 0. I'm going to put an open circle here and then connect those with a straight line. Now you have that part of the graph. And notice these are disjoint and not connected. It's not a continuous curve. Lastly, we have when x is greater than 0, and we have this function. And I recognize as a quadratic. I'll give myself a few points. So notice it includes 0 as a reminder. So if I enter f of 0, I get 0 squared, which is 0. So that gives me the order pair 0, 0. And that is included in the graph because I'm saying x equals 0. Use that. If I enter 2, just for fun, I get 4. So that gives me the ordered pair, 2, comma 4. So 2, comma 4 is right there. And then again, if I enter 1, I know I get 1. And you know what a parabola looks like. It's not a straight line, it's a curve. So again, do my best to, and then it picks up a little fast after that. So I'm going to try and draw the best of my ability and curved graph. And this goes on forever. So I'm going to put my arrow indicating that. And there's the graph of a piecewise function for this particular function. Okay, let's draw a graph another piecewise function. Now I'm only have 2 functions, and I made them a little bit messy so you can practice strategies. So I have 2 situations when the variable here is less than -1 but not equal to it. So I'm going to mark it right here so I can see it pretty clearly. And when x is greater than 2, not equal to 2. So really what I have is, here's my domain. What is the domain of this thing? As a reminder, the domain is going to be -infinity to -1, don't include -1, and then it picks up at 2 for some reason and goes out to infinity. So there is this empty gulf right here. So now let's graph both of our equations. So I got y equals 3/4 x for this range. So now what do? Well, I can use what I know about lines. I can exploit that. So, I mean, basically I have 2 lines. So I only use 2 points for each one. What's the y-intercept here, as a reminder? Again, you notice there's no b here, there's nothing here, which means that this must be a 0. So the y-intercept is 0, 0, and I'm going to mark it right here. And you're going, wait a minute, but that's outside of this. That's right, I'm not going to create a line. My line's got to stop right here. But I can use the fact that my slope, for example, is 3/4, and that's a rise of a run situation. Or I can make it -3 over -4, again, giving me positive 3/4. So I'm going to just use that strategy for the moment. So that means I travel 3 down, 1, 2, 3, and 4 over. Oh, gosh, what a mess. I mean, my graph paper here doesn't do anything for me. But if I try to do something like that. So, you know, you're going to have to you don't have to be exact. You have to get a little messy now. One thing you can do is look at it from the perspective of this. If I were to write this as a decimal, again, just trying to change things up a little bit. If I wrote m as a decimal, it would be 0.75. See if I have 1, 2, 3. Yeah, perfect. I did it right, unbelievable. But then I can think of it as a fraction, -0.75 over 1, right? 3/4 is 0.75. So now, again, I'm maintaining the ratio. I can think of this as -0.75 over -1. Negative over negative is positive. So that means I'm going to go down 1, 2, 3, because remember, this is 1, so 3/4 is 3 of these lines, 1, 2, 3, and then over 1. There's your point. And I'm not, that's not going to make that a circle because I'm not including that. Okay. And then from this, I'll do the same thing. Mark 3 little lines and 3/4 of them, 1, 1, 1, 2, 3, and then over 1. And this is a straight line, so all I got to do is connect those 2 points. And it goes down forever, so I'm going to put an arrow here. Right. So there's one function. Okay, got that out of the way. Let me now concentrate on this one. And notice how I'm writing this down. So even if somebody were to come back later, even myself, and read it, I should be able to follow. Notice I'm declaring which function I'm messing with. Then I started writing information that I know about this function. Hopefully is easy to follow. But now I'm going to move another line, different function. My slope is 1/3. My y-intercept, notice again how I'm declaring everything. I'm not just writing 0, 0. I'm declaring what it is that I'm writing down. Nope, sorry. I'm just looking over here. So in this case, the y-intercept is 0, 1. So let's mark that. 0, 1 is right here. Okay. And now what's my slope? The rise of 1 over 3. Okay, rise of 1 over 3. So if I rise 1, and this time I am going to be contained nicely. 1, 1, 2, 3. Oh, perfect. And you're going, well, how perfect is that? I mean, this point is not on here. And you're right, but I can again grab my ruler, come over here, and see that this is my starting position at 2. There it is. I'm going to mark it. Then I'll create a little circle. None of this is perfect. I mean, see there goes. See. Yeah, it's right here actually. Look at the ruler. One more time. Yeah, that's about right. So now it starts here at 2. That's about where 2 is located. And if you want to get more precise, you can always enter 2 into this, or right, y equals 1/3 times 2 plus 1. So I get 2/3 plus 1. So it's 1 1 1/3. So yeah, this is a little off, but that's okay. It's hard to tell. And there you go. That's what that function looks like when I do it this way. And I'm finished graphing it. So notice what I have done. I've kind of reminded myself here where it stops and ends, where the pieces. Sometimes this whole thing is continuous, but here I saw they were completely disjoint. So meaning that the ranges are not continuous for each separate function. And I was just able to kind of declare it faster that way.